This lesson looks at the workflow with built-in remediation and the various component objects. Our intention is not to bury students in layers of coding or a profusion of objects. There's no doubt that Automic experts will build far more elegant solutions than what's presented. We design a basic remediation system involving built-in failures using entry-level objects. We'll use jobs, workflows, calls, PromptSets, filters, and task properties. We'll also go over the ServiceNow components. Let's be clear, this is an almost comically simplistic model. The rationale is only remediation. We're trying to postpone human intervention with simple stopgaps until we've run out of automated options. So our process only involves a few basic features and no coding. The structure revolves around jobs, workflows, and a file transfer, which is the central process. To this, we add functional mechanisms to automate return code management and notifications using two types of objects: filter for output scans and a call object. We rely on PromptSets to simulate failures, as well as ServiceNow as our last resort. Much of this is handled with variables, especially the ServiceNow integration. Finally, pre- and post conditions play a key role in delivering a coherent mechanism. We've created a workflow called use case. We start with the prompts and variables that define the initial circumstances of execution. We have a few variables assigned to the workflow. They apply to all embedded objects. Two variables store yes/no values set by responses provided by the two prompts. We ask users if they want to create some test files and / files so that the directory quickly runs out of space. This is stored in response. Later, users are asked if they want to attempt the scrubbing of the / files archives. Clean res stores yes or no. Two prompt sets execute when the workflow activates. Choice asks users if they want to create test files and then saturate the target directory to simulate a file transfer failure. Clean asks users if they want to clean the archives and create space for the transfer to complete. Note the default values: yes for the former and no for the latter, which means the file transfer will fail twice and trigger the ServiceNow processing path. The data reference is a yes or no type. The variable is response, and it's set manually by the user based on the response. Filter object output scans the output of the file transfer and looks for a string of characters. When any instance of JOBF fails due to a lack of space in the target directory, the standard output writes not enough space. Our job is to capture this so that we can condition workflow behavior. We have a notification called DISSpace. This is a simple console message with a subject line and body. It states that the JOBF failed due to a lack of space. We have three jobs with embedded objects. The first creates test files that saturate the target directory, leading to a space issue. The task has a precondition. If users opt to create those files, then it executes. If not, it's skipped. The second job generates the file locally. The third task is the transfer. The output scan page shows the filter object scanning for not enough space and sets the monitoring status with a more meaningful status. It sets the return code to 1 and executes the call object. Finally, the archive cleaning job is conditioned by the response to the second prompt. This is the ServiceNow block based on the action pack. ServiceNow actions are pre-configured using standard PromptSets. The connection is supported with a URL field, which we decided to store in a variable in the main workflow. Core configuration information is always set in the third prompt from the top. The title of the prompt determines the operation performed by the task, in this case, create an incident. On the right, the fields include short description, caller ID, and some fields in a JSON expression. We'll come back to this. ServiceNow tasks are submitted via the REST agent. This task appends a comment to the incident. This task updates the state of the incident to in progress. This task creates a change request, prompting IT operations to perform a task. We use this to have an operator clean out the archive so that the workflow can proceed. The CR2 has a JSON area for extra fields. This task requests status of the CR approval. Note the system ID field, which is central to ServiceNow. We'll come back to this. The CR approval status request requires a post condition because this is a GET request, meaning it's waiting for information back from ServiceNow. Workflow processing is contingent on the status variable having value approved. Finally, note that Automic needs to authenticate with ServiceNow each time it submits a task.